Welcome back to Astronomy. This is chapter 12 on asteroids, comets, and dwarf planets. And in this final video, part 5, we're going to look at cosmic collisions, and particularly when these things strike Earth. Our goals for learning: did an impact kill the dinosaurs? How great is the impact risk today? And is there a defense plan against these collisions? This is an image of comet Shoemaker-Levy 9, we'll just call it comet SL9. It caused a string of violent impacts on Jupiter in 1994. And you'll notice the scale down below. It shows 100,000 kilometers, and I've put in there some tiny planet Earth. So relative to this whole picture, though each of those little blue circles is one planet Earth. What you're looking at in the image is the comet Shoemaker-Levy 9 that, because of tidal forces from Jupiter, it got ripped apart into many, many different parts. And when we see the impacts that happened on Jupiter, it reminds us that catastrophic collisions still happen today. Here's an artist's conception of the impacts on Jupiter. The impact sites in infrared light. And when those parts of the comet impacted with Jupiter, we get the next picture. These are the scars left behind, and I've given you a scale comparison of the planet Earth compared to those scars. And you can imagine what might happen if one of those parts or the entire comet had hit planet Earth. It would be very devastating to life on Earth. So talking about devastation to life on Earth, let's look at the idea of major impact killing the dinosaurs. And here's an artist's conception of what is believed wiped out the dinosaurs about 65 million years ago, and either asteroid or comet, some kind of meteor, striking the Earth. So something large enough striking the Earth can cause mass extinction. Fossil records show throughout the history of Earth, or for as long as there's been life on Earth, occasional large dips in the diversity of species. So every so often, every few tens of millions of years, there is a large decrease, sudden decrease in the diversity of life, and it's believed that those were mass extinctions. And the most recent one was 65 million years ago that ended the dinosaurs on Earth. So the evidence that it was a meteor that wiped out the dinosaurs. Iridium is an element. It's very rare in Earth surface rocks, but it's often found in meteorites. So we know that there is iridium up there in space. And two scientists, Luis and Walter Alvarez, found a worldwide layer containing iridium. And so all around the world, there is this layer of iridium, and they can find the timing of it based on the sedimentation of the rocks. And it's at a level down under the rocks that shows that it was laid down about 65 million years ago, probably by a meteorite impact. So it's figured that something from space, a meteor, hit and had a worldwide impact. So this iridium layer was laid down about 65 million years ago, which coincides with when we see in the fossil layer the dinosaurs disappearing. All dinosaur fossils lie directly below that layer. And so here we can see one such site where they found this. This is a thin layer containing the element iridium, which again is very rare in Earth rocks. And below that layer is dinosaur fossils. Above it is no dinosaur fossils. The consequences of such an impact. It's figured that it was a meteorite that was about 10 kilometers in size. So that's about 6 miles in size, that upon landing on the Earth would send large amounts of debris into the atmosphere, basically covering the entire sky, darkening the sky. The debris, which would spread worldwide, would reduce sunlight that reaches the Earth's surface. The resulting climate change may have caused mass extinction. So they've even found where that meteor hit, and right here, the Chicxulub crater on the Yucatan Peninsula in Mexico. So there is a crater. Some of it is off in the water in the Gulf of Mexico, some of it is on land. Zooming in a bit, there you can see in the small picture the red rectangle on the Yucatan Peninsula. And we zoom in, and what this shows is this white curve is the shoreline. And so below it is the land, and above it is the sea. And so they found this crater right there. Geologists have found this large subsurface crater about 65 million years old in Mexico. Interestingly, on land, all around the perimeter of the crater are many sinkholes that are filled with water that people sometimes go enjoy swimming in, these very deep sinkholes. Again, there's the artist's conception of such an object about 10 kilometers in size coming towards Mexico. Now let's talk about risks today. And here's a picture of a meteor that actually exploded above the ground. We'll get to talk about that picture in a minute. Asteroids and comets have hit the Earth in the past. We know that, including times that have been witnessed by people. A major impact is only a matter of time, not if it will happen, but when. So the last one happened 65 million years ago, and it's bound to happen again. It's just a matter of when. Major impacts are very rare. Extinction level events happen millions of years or even tens of millions of years apart. Remember, the last one was 65 million years ago. Major damage, not extinction, but major damage happens tens to hundreds of thousands of years apart. So let's go back to that picture that I showed a few minutes ago. This was Tunguska, Siberia, so northern Russia, June 30th, 1908. An object approximately 40 meters in size came in from space, and it actually disintegrated and exploded in the atmosphere. It knocked down trees, even tents and settlements and people for hundreds of miles around. More recently, in 2013, this meteor was created by a 20-meter object over Russia, and this was caught on somebody's dash cam. This footage has been used. It was used in a major science fiction movie, and unfortunately, I can't remember what movie it was, but it was a movie probably about an alien attack. But this is actual footage that somebody caught of this meteor. Now, that meteor, they found it on the ground. So the largest chunk of the Chelyabinsk meteor, right, is 60 centimeters in size and weighs 1,442 pounds. And here's a picture of it. Frequency of impacts. Let's look at this graph here. On the horizontal axis is the size of the impactor. So we have 1 meter, fairly small, 10 meters, 100 meters, up to exceedingly large would be 100 kilometers. So that would be about 60 miles across. And we're relating that to the vertical axis, how often it happens. So down low would be maybe once in Earth's entire history, and up top very frequently, maybe once every hour. So what we see, there's a rough correlation. We see that small impacts happen almost daily. Somewhere around the world, we get these little small impacts. And most of them are going to hit in the water because the Earth is almost 3/4 covered with water. Impacts that are large enough to cause mass extinctions may happen many millions of years apart. Let's look at the graph. So let's look, for example, at where my pointer is, 10 meters in size. That would happen about once every year, roughly. And so anything in size from about more than a meter to hundreds of meters would cause a small atmospheric explosion, or I'm sorry, an atmospheric explosion or a small crater. And again, the bigger it is, the more devastating, the rarer it is, fortunately. So we get to the high end of that, and we're looking every few thousands of years. We get to things that are hundreds of meters to a few kilometers across, and we're looking at tsunamis, widespread devastation, climate change. And then we get to the extreme things, mass extinction. These would be objects that are pushing 10 kilometers in size or larger, but fortunately they happen only every tens of millions to 100 million years. This is Meteor Crater in Arizona. It's about 1 kilometer in diameter, and it was caused by an impact several tens of thousands of years ago. The impactor that caused it was 50 meters in size. So 50 meters in size causing a 1,000-meter diameter crater. And that's kind of a rule of thumb. If we're thinking how big is the crater compared to the thing that caused it, the rough rule of thumb is you take the thing that caused it, multiply by somewhere between 10 and 20, and that gives you a rough estimate of what kind of crater it would cause. So something 50 meters in size would cause a crater that's about 1,000 meters or 1 kilometer in diameter, such as you see here. And Meteor Crater is actually a tourist attraction for anybody interested in geology or astronomy. Here it is off of Google Maps. I looked up Meteor Crater in Arizona, and if you're ever passing through Arizona, we have I-40 and there's Flagstaff and Meteor Crater right there. Now, these impacts that I'm talking about could be comets, which are balls of ice, or they could be asteroids, which are rocks. Most likely, it's going to be a rock, so an asteroid. And astronomers are interested in tracking what's called potentially hazardous asteroids. Sometimes they're known as near-Earth asteroids. So near-Earth asteroids are asteroids that pass around Earth's orbit. So these are not asteroids that are contained in the asteroid belt. They are in more of the inner solar system near Earth's orbit. A potentially hazardous asteroid, or PHA, is defined as a rock larger than approximately 100 meters that can come closer to Earth than 0.05 astronomical units, which is 19.5 lunar distances. So again, potentially hazardous asteroids are those larger than about 100 meters. This chart here, found on spaceweather.com, you can look it up any day you want to. You can go to that website and find recent and upcoming Earth asteroid encounters. Now, so these are near-Earth asteroids, and it says on March 23rd, 2024, there were 2,349 potentially hazardous asteroids. So these asteroids that are somewhere around Earth's orbit. Now, if you look at this list of asteroids that are coming near Earth this particular week, and it's showing from the 17th of March to the 29th of March, and it gives the miss distance. So all of these asteroids, we discover them, and then we track them. We track their trajectories to see if they're going to be some threat. The miss distance refers to lunar distances, which is defined as the distance between Earth and the Moon. So this one at the top, which is the closest one on this chart, is 0.4 lunar distances. So you can imagine the distance between the Earth and the Moon, 4/10 of that. That's how close it comes. Sometimes they come even closer, 0.1 lunar distances. I've seen on this chart many times. A few times over the years, I've seen it actually say 0 lunar distances, which doesn't mean it hit the Earth, but just simply that it came close enough that as they're listing them only to the tenths of a lunar distance, it rounded down to 0.0. But that's pretty rare. It gives the speed, it gives the diameter. So this one is 12 meters across. And so you think if this were to hit the Earth, not that it's going to, but if it were to hit the Earth, multiply that number by about 20 to give you a feel for what the size of the crater would be. 240 meters, that's about 2.5 football fields in length for its diameter. We have some larger ones. There's one here, 140 meters. So that crater, if it were to hit the Earth, would be several kilometers. Although notice its miss distance, 18.8 lunar distances. That is very safely far away, 18.8 times farther than the moon is from the Earth. Now here's something that is a bit frightening. If you think, how long have we been tracking these asteroids? Well, look at the names of these asteroids. Asteroids are named with a letter and number designation, but the first four digits are the year it was discovered. So for example, the one where my pointer is at, 2020 FD, which means it was discovered in 2020, and they've been tracking it ever since. But notice the far majority of these asteroids were all discovered in 2024, which means a year ago, they didn't even know they existed. And the chart typically looks like this. You look up for any day, any week, any month or year, you look up on spaceweather.com, you see this chart, and the majority of asteroids on the chart were just recently discovered that year, which means whatever asteroids are going to appear on the chart, say a year from now, we haven't even discovered those asteroids yet, and we won't discover them until they're coming near towards Earth. So that gives you a little sense of, that's kind of scary. When they come near Earth, that's when we first discover them. So what are we doing about it? What is the defense plan for defending the Earth? NASA has a project. I'm going to tell you about a mission that it did that was successful. The idea was to aim a spacecraft, a robotic spacecraft, at an asteroid, and if it's coming towards Earth, to be able to deflect it, not to blow it up like was in the movie Armageddon several decades ago, not to blow up or destroy the asteroid, but simply to deflect it off course if it's heading towards Earth so that it won't hit Earth. The mission was the Double Asteroid Redirection Test, or DART. And the mission, it began November 24th, 2021, and it was successful. The mission ended September 26th, 2022. NASA aimed at testing a method of planetary defense against near-Earth objects. So here is the DART spacecraft. And what we were aiming at was there is a double asteroid, so Didymus and Dimorphos, the double asteroid. And the idea was to go after the smaller asteroid and to hit it in such a way that it deflects it and changes its trajectory. The asteroids aimed at, there was Didymus A, that's the larger asteroid, about 780 meters in diameter. And what we were aiming at was Didymus B, otherwise known as Dimorphos. It's about 160 meters in diameter, so you picture a rock that is almost 2 football fields in size. And Dimorphos was in an orbit about 1 kilometer from Didymus A, just orbiting around Didymus A. The double asteroid system was about 11 million kilometers away from Earth in 2022. And putting that to scale, 11 million kilometers is about 29 lunar distances, or 0.07 astronomical units. Now, thinking back to the chart about what kind of damage could Dimorphos do, Dimorphos is in the size range of asteroids that one would want to deflect were it on a collision course with Earth. So its size of 160 meters puts it about right here on the chart. It is something that would cause atmospheric explosion or a small crater. And small crater, well, compared to the planet Earth, small, but for us, that's a big crater, I'd say, because 160 meters, multiply that by 20, you're looking at a several kilometers in size crater that it could cause. So the test was to see, do we have the ability to deflect an asteroid of such size? And so here, this is a picture from the spacecraft of Didymus and Dimorphos. Now, at this distance, this is actually, here it is, and then it's zoomed in a bit. And so you can't see Dimorphos, the smaller one. So this is just the Didymus A and B system. This is a picture. The spacecraft was continuously taking pictures as it was approaching. So right now, that dot in the middle is Didymus A and B. And you can't even make out that it's two separate asteroids. But as the dart approached, we now have this, so Didymus and Dimorphos, which was the target, and so it's going to bypass Didymus and go straight for Dimorphos, aiming to hit it. And so here it's getting closer, and it gets closer, and it gets closer, so this is moments before the impact. Split second before the impact. And then this was the last picture that was taken right before it impacted, and you only get that little bit that was generated, and then it went black. So the DART spacecraft was destroyed, and it did successfully redirect the asteroid by the amounts that they had been hoping to redirect it. So the mission was a success, and what it showed us was that we have the ability to deflect a large asteroid if it were on a collision course towards Earth. So in this video, what have we learned? Did an impact kill the dinosaurs? Yes, most likely. There's an iridium layer just above the dinosaur fossils that suggests that an impact caused a mass extinction about 65 million years ago. And there's a large crater of that age that's been found in Mexico. How great is the impact risk today? Large impacts do happen, but they are rare, and they do cause major extinctions about every 100 million years or so. Now, we're about due because the last one was rounding up to about 100 million years, and so it's good that the space agencies, particularly NASA, are putting together, working on a plan to divert such an asteroid if it were to come towards Earth. And that is the end of chapter 12. Have a great day.